Hey, eighth grade. So our learning target today is I can write equations of parallel lines in slope-intercept form. You should be on page 16. So we're talking about what parallel lines look like when we have, parallel lines since elementary school, but how do you write the equations of parallel lines? So parallel lines, basically what you're looking for, if two lines are parallel, they have the same slope. So a very important piece of what we do in eighth grade math. Looking at their slopes, if two lines are parallel, they have the same slope. So if two lines have the same slope, they're parallel. So it kind of works both ways. Parallel lines, same slope. So you can see that these two lines down here are parallel to each other, which means they'll never intersect into infinity. So if we were to write the equation for line M, we would first of all identify the b value. The b value in equation line M, the b value is equal to 2, because that's that y-intercept. Looking for the slope would be a rise-run situation. So we would have to identify a couple data points. I'm going to pick these two as my data points. I'm going to rise 2, and I'm going to run 3. So my slope is 2/3. My equation then in this top one is y equals mx plus b. So my equation is y equals 2/3 x plus 2. Y equals 2/3 x plus 2, mx plus b. Down in equation n, looking for my y-intercept and looking for my slope. So my y-intercept is down here at -2. So my b is at -2. My slope, I rise and run. So I'm going to rise 2, run 3. So my slope would be 2/3 again. Rise 2, run 3, m over my m and my b. So my equation then in this bottom one is y equals mx plus b, 2/3 x plus -2. If I take a look at just the slopes, you'll see that the slopes are the same. And when the slopes are the same, we end up with parallel lines. Parallel lines, same slope. So write two equations that are parallel. That's kind of up to you to fill in these two spots. You need to have two equations that have the same slope. So you can really write anything you want as long as the slopes match. So y equals, I'm going to say -1/4 x, and y equals -1/4 x plus 1. Those two lines are parallel because they have the same slope. Because they have the same slope. Okay, so if I'm looking at the slopes there, we can see that the slope is -1/4 and -1/4 parallel lines. So two lines that are not parallel, the key is that they have different slopes. So we could say y equals -1/4 x again. And then we could say y equals +1/4 x plus 1. Different slopes. If I look at the slopes, they look similar, but a -1/4 and a +1/4 are different. They'd actually intersect or hit each other. So there's some ideas of parallel lines versus not parallel. Okay, so we're going to look at this chunk of information down here. Determine if the lines are parallel. First of all, they all have to be solved in the form of y equals. Y equals, we're good there. Y equals, we're good there. We have some work to do in line C. So in line A, it's already in y equals form. So our slope in that problem is just 4, no work required. In line B, our slope is -1/4. No work required. In line C, we have some work to do. We're going to have to solve this for the variable y. We're going to add 4x, copy, paste. And I'm working this from left to right then. We have y equals 4x plus 1. So we have y equals mx plus b. So now that I've solved it for y, copy, paste, add 4x, copy, paste, my slope is 4. Taking a look at my lines A, B, and C, you can see line A's slope and line C's slope are the same. So we would say line A is parallel to line C. Notice my notation over here. Line A is parallel to line C. I like to put that in parentheses so it doesn't look like it's like the number 11, doesn't look like the number 1, things like that. Line A is parallel to line C. Line B does not fit in that mix at all. We'll talk about that. Line B is actually perpendicular, but that's in a later unit. Okay, so now you try in this giant box over here. So I'm actually, because it's the video, I'm going to actually have you do this with me in the you try. So the first example, line A is already in y equals form, so we just drag our slope down. Line B, however, is not in y equals form. So go ahead and solve that for y right now. Everybody should be solving that for y. We have x plus 5y equals 2. Okay, as you're starting to solve, you should be solving for y. Okay, as we're starting to solve, you should have come up with y equals 2/5 minus 1/5 x, or maybe you flipped it around using the commutative property. You know I like to stop, chop, chop that. So I grab that slope and take a look at the slope, negative 1/5. So you can see that line A and line B do not have the same slope, so they're not parallel. They're actually perpendicular. Again, we'll learn that in a later unit. So taking a look at line C, we have negative 10y minus 2x equals 0. We're going to solve that equation for y. Go ahead and do that right now, please. Everybody should be solving for y. Add 2x, copy, paste, hand method kicks in. Go ahead and work through that. Everybody solving for y right now? All right, as we start to solve then, so we're going to add 2x, copy, paste. We end up with this as our negative 10y equals 2x. Get y home alone, we divide by 10, copy, paste, and we end up with y equals negative 1/5 x. So you can see that our slope there is the variable, or is the thing that's attached to the variable x, so negative 1/5 is our slope. So this particular time, you can see that these two slopes match. So line B and line C, since they have the same slope, we would say that line B is parallel to line C. We'll say that line A is perpendicular, but that's in a later unit, so we can't really talk about that right now. That line B and C parallel, that's our goal for today's work. We're just looking at those slopes to see if it's the same slope, means it's growing at the same rate, parallel lines. All right, so that's to get us started. So what do we would say as our notes? All right, write an equation of a parallel line. First of all, you have to identify a parallel slope. So you have to, if you're going to write an equation of another line that's parallel, for sure their slopes are the same. Then use a parallel slope and a point to find B. You've done this process before, but the parallel line is kind of new, the new piece of this puzzle. Hand method will kick in, and then we just plug back into the equation. So those are 3 steps. Go ahead and take those notes there. So you're just filling in those blanks. All right, so let's talk about how we write an equation of a line that's parallel. So we have down below is we have y equals 3x minus 1. So let's first of all go graph that. We'll fast graph it. I'll say no, we stop, chop, chop. We have a y-intercept of negative 1. And we have a slope of 3. A slope of 3 means really 3 over 1. Rise 3, run 1. So we're going to go ahead from that y-intercept. We're going to rise 1, 2, 3, run 1. And there's our line. The line that's given is this line here. What we're looking to find is a parallel line to that. Using the same slope. We know if it's a parallel line, slope's the same. So we can use the slope 3 again for a parallel. This right here, notation means parallel line. What we don't know is the b value. That's what we're going to work to find. We know the slope should be the same. We can pick the x, y value from the question. Sorry. The x, y value that it goes through is negative 3, negative 5. So we're going to use that, negative 3, negative 5. So we have a point and we have slope. We can go point slope form on this and solve, or we can go y equals mx plus b. Either way, it doesn't matter. And you can solve this. I'm going to go point slope. So we have y minus negative 5 is equal to my slope. And then I have x minus negative 3. We're going to solve this entire equation for y. So I stop, chop, chop on the left. I use the distributive property on the right. I have a lonely variable there. I need to kill the parentheses. So I distribute. Gives me 3x plus 9. On the left-hand side, we have y plus 5. Hand method kicks in. So we solve for y. We subtract 5, copy, paste. Sorry about that. My pen is moving some things around here. So we're going to subtract 5, copy, paste. Working left to right then. We have y equals, we have 3x plus 4. So there's our y equals mx plus b. You can see that those slopes are the same as they should be. If they're truly parallel, we should have same slope, same growth of the line. Y-intercept is different, so let's go ahead and fast graph this second equation in blue. Our y-intercept is 4, so that's it, where the line crosses the y-axis. It looks like we run out of room there. You're going to have to estimate that. Sorry about that. Way up here is y equals 4. My slope is rise 3, run 1. I'm going to run out of graph. So instead of rising up 3, running 1, I'm going to have to do the exact opposite, which is down 3, left 1. I'm out of space on that graph, so I'm going to go down 3, down 1, 2, 3, left 1, down 1, 2, 3, left 1, looking for a parallel line. And you should see that these two lines are indeed parallel to each other. At least they're supposed to be. You can see that I'm not super great at drawing a straight line. Sorry about that, guys. Okay, so we see two parallel lines. What's key is that their slopes are the same. We found the y-intercept using point slope form. Meet me on the top of the next page, page 17. So page 17, example number 2. Okay, example number 2. So write an equation of a line that passes through -2, 1 and is parallel to the line that you see. So the line that we see is y equals -x plus 5. The slope of this line is -1. So a parallel slope then would have to be the same slope. So the parallel slope would be also -1. Parallel slope -1, same slope. We don't know the y-intercept of the new line. And we know that it goes to the point -2, 1. So we have a point and we have a slope. So you can either go y equals mx plus b on this equation, or you can go point slope. I'm going to go point slope. So we go y minus 1 equals, my slope has to be the same if the lines are parallel. So we have already identified that as -1. And we have x minus -2. Hand method kicks in. I have a lonely variable there, and I'm going to stop, chop, chop on that back side. Stop, chop, chop here as well. So we have y plus -1 equals, using the distributive property to kill that parenthesis, we multiply through as -1, reattach the variable x, keep the sign. Distribute again as -2. Hand method kicks in, solving for the variable y. The opposite of -1 is +1, copy, paste. If I'm going too fast, go ahead and pause that video. All right, cleaning this up then, we drag that y down. If I haven't used it, we drag it down. A -1 and a +1 is 0. On the right-hand side, if I haven't used it, I drag it down, which is -1x. And then we have -1x plus -1. So this is the line that's the equation of the line that is parallel. You can see -1x is the slope up here, -1x is the slope down here. Y-intercepts are different. Go ahead and fast graph those. You should end up with two parallel lines. As you're solving, then you end up with two parallel lines, different y-intercepts, but they're parallel because their slopes are the same. Go ahead and keep working through that. Make sure you end up with those two same parallel lines. Start at your y-intercept, run your slope from there. Okay, guys. So moving on to the last question. Try this last question. This one's going to probably take us a little bit of time to solve. So what is the equation of line that passes through T and is parallel to PQ? So here is the point T down here. So point T is down here. It looks like point T is located at -2, -3. So what we were looking for is we're looking for a parallel line to PQ. So let's first of all write the equation of the line PQ. Line PQ. Line PQ, we're not sure of the y-intercept there, but we know that it has a slope. Here's my slope. Here are my two data points. It looks like we're going to go down 2 over 7. So my slope is down 2 over 7. My equation then would be y equals mx plus b. The problem is I don't know the b value right now. And because I don't know the b value, I can't write the equation. However, I can take one of these data points and use its slope to figure out the b value. So the slope, the data point I'm going to use is this q data point. It looks like it's right 5 up 2, right 5 up 2. So the x value is 5, the y value is 2. I can write an equation then in point slope form to find the b value. So I'm just working on the line of PQ right now. So we'd say y minus 2 equals the slope. And then we have x minus 5. Going ahead and solving this, looking for that b value. So on the left-hand side, we have y minus 2. I'm going to stop, chop, chop that so I don't make any sign errors. On the right-hand side, we have this lonely variable, and I have a stop, chop, chop, killing that subtraction. Distribute to kill parenthesis. We get -2 sevenths, reattach the variable x. Distribute again is -10 sevenths. Working our way down this problem now. I'm going to add 2, copy, paste. So we end up with y equals 2/7 x plus, I have some work to do over here, that's -10 sevenths plus 2. Finding a common denominator there, I'm going to multiply by 7 over 7. -10 sevenths on the left plus, that becomes 14/7 over here, is positive 4/7. So my equation is y equals 2/7 x plus 4/7. So I'm looking for an equation of the line that's parallel to that. So we have PQ is 2/7 x plus 4/7. A line that's parallel that goes through the point T. Well, this is what we know about the point T. We know the point T goes through negative 2, 3. And we know the slope is the same. So we have to have if we're working on a new equation, we have to use the same parallel slope. So slope has to be parallel and it has to be 2/7. Problem is we don't know the b value, but we do know a data point that it goes through is negative 2, 3. Okay, I'm going to erase that there so we have some space to write. So I'm going to use point slope form, because I have a point and a slope, to find the b value. So we have y minus 3 equals, the slope is 2/7, because it's parallel. We're looking for a parallel slope. And then we have x minus negative 2. Point slope form. I'm using the point xy, and I'm using a parallel slope. I'm looking for the equation of the line that goes through T. We have a lonely variable here, and we're going to have a stop, chop, chop. Using the distributive property, we distribute, which is 2/7, reattach the x, plus distribute here. Multiply tops, multiply bottoms. 2 times 2 in the numerators is 4. Multiply bottoms, 7 times 1 is 7. Working left to right here. Our job is to get the variable y all alone. Hand method. Take my hand, cover the variable y, get rid of the plus negative 3. Closest sign wins. Sign closest to the 3 is negative. Opposite of negative 3 is positive 3. Copy, paste. Working left to right then. So we end up with, if I haven't used it, drag it down. If I haven't used it, drag it down. Over here, I have this 4/7 plus 3. Working on that. Finding a common denominator, I'm going to multiply this by 7, copy, paste. So that ends up with 4/7 plus, that becomes 21/7. So that becomes 25/7. So my equation is y equals 2/7 x plus 25/7. All right, so I'm going to erase all this stuff. So my two lines that are parallel are PQ, which is y equals 2/7 x plus 4/7. I'll go ahead and highlight that in yellow, is parallel to this line here that goes through the point T. So those two lines are parallel to each other. What we would need to do is we would need to solve all of these for y to see which one matches up with that equation. So your homework, well, let's talk about summary. For our summary then, for tonight, couple of things. Lines under the parallel have the same slopes, but different y-intercepts. If they had the same slope and the same y-intercept, they would be the same line. So be careful about that. Same slope, but different y-intercept. Make sure we always rewrite in the equation y equals. So we kind of didn't finish that last problem all the way. We did find the equation of a line that's parallel, but I'm going to ask you now to go A, B, C, D on page 17. Solve all of those for y and find out which equation is a match. You can go ahead and look on my website if you want to see the correct answer. Okay, so you can go ahead and check my website to see if you end up getting that try this one correct. I'm not going to give it to you right now in the video. I want you to actually solve all of these for y and find out which one of those is going to give you this match. Okay, that's your job to figure that out. You should be filling out your summary on the bottom of page 17. Your homework for tonight is to finish page 18, page 19, and page 20 due tomorrow. Page 18, 19, 20 due tomorrow. Have a fabulous night, 8th grade.